Okay, guys, this is the worksheet that I'm giving you today. And I'm gonna work through this first problem with you and kind of explain how to set up an ice table. And then you should be able to practice just filling in an ice table. And then I'll do another video where I actually practice one of the problems to see you all the way through it so that you can see me work all the way through one. So first, let's just set up an ice table. You're given concentrations. Notice you're given uppercase M, which is molarity. And you're given the actual balanced equation. You want to do first make sure it's balanced. And then you just begin to fill in your ice table. At the top, you're going to put your reactants in order, and then your product. You're going to fill in the initial concentration. So the initial concentration is 1 molar for sulfur trioxide, 2 molar for water. The initial concentration of your product is always going to be 0 because remember, this is the beginning of the reaction. You have this strength of reactants, you have not made any product yet. So initially, the concentration of your product is going to be 0. As the reaction happens, it's going to begin to change. Well, the change is always going to be a variable used to show that you have this concentration, but it is going to change. He's going to lose some of his concentration as this reaction happens. So we say negative X because he's losing some of his concentration. And then we just use X as a variable for it's going to change by a factor of something. We don't know what that is yet. That's one of the things we can try to figure out. Same thing with water. The value that you're given on the variable is based on the coefficient. So since the coefficient here is 1, we say minus 1x, but we don't show 1s. And here we see that our product is going to be gaining something. He's going to be gaining some of that concentration that your reactants are losing. So we say he's plus some variable. So at the bottom, the equilibrium is just equal to the concentration that you're starting with based on the concentration that you're going to lose. We don't know what this is yet. We can calculate it. So the equilibrium equals the initial concentration minus that change. The equilibrium for water is his beginning concentration minus that change. And then we say our product equilibrium is going to be whatever he started with plus some value that we haven't calculated yet. So he's simply 0 plus X or just X. So that's how you fill in the table. Every single time, same steps.